Got the volume on. Good. Okay. How are you doing, Matias? Good to have you here, sir. Let's see. Okay, so guys, let's see. I did send y'all a message the other day letting you know that the notes were up for this week. And dry your eyes, y'all, because why is that only showing up there? Why is it there we go. Okay, so dry your eyes because this is the last thing that we are doing. So yeah, let me pull this up right here just so we can kind of go over like like an overcap or recap or yeah or review of what we're gonna do. So guys, I do have the notes for 6.4 right here. Let's see. So today is May 2nd. Today, all we're gonna do, guys, go over 6.4. The homework is due a week from tonight. Okay. So this coming Wednesday, as in 2 days, and next Monday, all we're doing, y'all, is reviewing for the final. Okay. So guys, remember the review for the final. Let me kind of go back to that folder right there just so you can see it. Here we go. Final exam review and final exam. And here we go. Here's the final exam info. Okay, so the review, y'all. Still, I thought I changed that, but apparently I did not. Let's change it real quick. Okay. So the review for the final exam, y'all, has 30 questions, right? So this Wednesday and next Monday, all I'm going to do is just say, what kind of questions do you guys have that you want to ask me about? Okay. So I was thinking that maybe on Wednesday we could say, look, let's take a look at the first 15, and then next Monday we can look at the next 15. Does that make sense, right? So that we don't have to like worry about, okay, let's go through all 30 questions in one day. We can do it in chunks, right? And guys, we have time. You know what I mean? The final exam, y'all, is going to open up next Monday as soon as class is over. Now, the only thing is, y'all, and I think I put it on here. Here we go. It is due by 8 o'clock on Thursday, the 12th. Okay, so normally everything is due at midnight. That day, guys, it's due by 8 because I have to get my grades turned in. Does that make sense? So you know what? Let me do this real quick. Edit. Here we go. Mm-hmm. Let's go like that. Let's color this. Let's go in red. There we go. So at least it stands out a little bit more. But the final exam, y'all, is due by Thursday, May the 12th. Okay, so the review is due that same day as well. So you're going to have really Monday afternoon, Tuesday, Wednesday, Thursday to do your final, right? 20 questions, so it's not going to be a lot. Again, guys, there's no time limit. So if you want to do it in chunks, that's fine with me too. I did include the formula sheets, all that kind of stuff. But what I'm thinking is, again, this Wednesday we'll go through the first 15 questions from the review, and then next Monday we'll go through the next 15 questions. And this way, we have time to go through it. I don't want to rush through it. It is the final. It's worth just the same amount as test one and test two were due, right? Still 20% of the grade. So even though we're at the end, I don't want you to feel like, okay, I'm already done, right? Because I still have that 20%, you know what I mean? And I want you to do well and all that kind of stuff. But like I said, in terms of new material, guys, today is the day. This is the last thing I'm going to teach you. And if you do have your calculators with you, you're definitely going to want to use them because we are going to use these problems here, y'all. We're going to use our TI calculators to do them, okay? And Noel and Matias, I know Matias, you have the TI as well. Noel, I'm not sure if you have a TI as well. If you don't, well, let me ask you. Let me just be real direct. Noel, do you have a TI instead of saying if you don't? Yeah. So let's see. Hello, hello. So Noel, whenever you get a chance, chime in. And do you have a TI calculator? No. What kind of calculator do you have? Do you know? Is yours Casio? Oh, Casio. And but it's graphing. Okay. So, man, I'm not certain how to use the Casio, but you might know, and we can look. We can definitely like Google it if we need to. You know what I mean? So let's see. Okay. So anywho, guys, I have the notes here for 6.4. So 6.4 talks about arc length of a curve and surface area, and actually we're just doing the arc length of a curve. So we're trying to figure out the length of a curve over a particular interval, okay? Yeah, it's going to be very straightforward here, y'all. And this is going to be, like I said, this is going to be very calculator. That's not what I wanted to do. Come back over here. That's where I'm trying to get to. Okay, so we're trying to find the length of this curve over a particular interval, okay? And so if you can kind of look at what they're doing here, they're saying, look, we're going to do like these little approximations. We're going to find this distance here, this distance here, this distance here, you know, kind of like, you know, what's the distance in those little pieces? And the idea is, y'all remember, so when we talk about area or volume, we do this over these really small increments. But then when we add everything up, we get the length of the curve, right? So in essence, that's what we're doing here. And we have a formula for the length of a curve. So the way we find the length of a curve is it's going to be the definite integral from A to B of the square root of 1 plus f prime of x being squared, okay? So look, let's see if we can go through a problem and figure this thing out. Let me actually keep this here because I want us to be able to access the formula as we need to. So the length of my curve is the integral from A to B of the square root of 1 plus f prime of x all being squared with respect to x, right? So I just copied the formula again. So the first thing I want to do here, y'all, I'm going to look at the equation that I have. So the equation I have here is y equals 4x squared minus 5, okay? So that's my f of x, right? F of x is 4x squared minus 5. I want you to notice what it is we're trying to find. We're trying to find f prime of x, but being squared. So before we find f prime of x being squared, let's find f prime of x. So what is the derivative of 4x squared minus 5? 8x, right? Okay. So there's my derivative, okay? Now, y'all, the formula says we want to know what the derivative is squared. So all I'm going to do is I'm going to say, look, what's f prime of x being squared? Wouldn't that be a 64x squared? Because I have to square the 8x, so 8x, 8x, 64x squared. Okay, so y'all, this is what we're going to do now. The length of the curve is going to be the integral. Look at the interval that we are evaluating this over. We're going from 0 to 2, okay, of the square root of 1 plus f prime of x being squared, which was a 64x squared dx. Okay, so that's the integral that I'm trying to evaluate. Now, y'all, when I was a calculus student, like I'm going to kind of take a back up here for a second. I'm going to my Blackboard page, and where do we have it? It's here somewhere. Here we go. In the general, yeah, in the general info, y'all, I want to say that here we go. We have an access to the textbook, right? So if I click on this thing here, let's see, here we go. I think this will open it up. No, that's not working. What about here? Let me see, is this doing it? Yep, this is doing it right here. Okay, so I'm going to go to my table of contents, okay? So, and I'm trying to see if it's in here. Here we go, y'all. If you notice right here, there's something called a table of intervals, okay? So when I was a calculus student, you know, I didn't have a PDF version of a book, right? I actually had a textbook. And when you would open up the textbook like this, right, on the inside covers, there was this whole table of all these intervals on there, right? And because there's so many different variations of intervals, sometimes what we have is we just have to use the formula, okay? So what we end up doing is you end up coming over here and you're like, look, I can see all these, look, here's the integral of, you know what I mean? Look, it's got all the, you know what I'm saying? It's got all this kind of stuff here, right? And it was easy for me to look at because, you know, you have a book and you open it up and it's right there, right? It's a little bit more visual as opposed to having to hunt for this kind of online thing here. No, nothing like that, nothing like that. But guys, I want you to notice something here. Let me see, I'm gonna come back to my problem. So I have the square root of 1 plus 64x squared, right? And where is it? Here we go. That to me looks somewhat familiar to this right here. You know what I mean? It looks something like that because it's the square root, and it's actually not this one because that's 1 over. I'm trying to see if there's one that looks maybe something more like this. You know what I mean? Because it's this square root kind of business, right? So you end up using this kind of ridiculous formula that we never really use, or we don't use it often, right? Because this is a definite interval problem, y'all, our calculators will actually do definite intervals. Okay, so let me show you how I'm going to do this on my calculator. So let me clear this stuff out. Okay, first thing I'm going to do, y'all, I'm going to hit my math button, and I'm going to scroll down until I find this one here. Look what it says. Number 9 on my calculator is function integral. So this is going to integrate. I'm going to go ahead and hit enter. Oh my goodness. Let me see if I can do this. Okay, I did this. Yes, I did this the other day, y'all, and I did it on my. Yeah, let's try it that way. And because guys, I did this on my calculator app the other day, on the app that I got from and it's just a little bit more straightforward. But let me try that. Let me see if I can do it this way. Oh man, I think it's going to look something like this. I think you're right. I think it's going to be. Oops. Yeah. So let me try it this way. Let me try to go 0, 2, comma. Okay, I'm going to hit second square root, and I'm going to enter what I have inside here. 1 plus 64x squared. Okay, close off my parentheses, comma, and I'm going to go x again, and I'm trying to see if this is going to work this way. Let me hit enter. Let's see. There's a go. Okay, we got a mistake somewhere. Okay. Okay. So let me see, y'all. And then you know what? Go ahead. Tell me, John. Have you found something? Uh-huh.
Because you do the equation.
First?
Yeah. Then the symbol, like X.
Yeah.
And then it's from.
Okay, so let's try this, and let's try this, and that, and that. Okay. So after the X, John, do I put my 0, 2 after that?
Yeah.
Okay.
Comma. 0, at least according to brownmath.com.
Yeah, 0, 2, and then do I do my X, or did I? Okay. So after this, put the X. Yeah. Oh yeah. I gotta close those parentheses there. So let me do that. Okay, there we go. Comma X, comma 0, 2. Let's see if it works that way. Nope, still making a mistake somewhere. What did I do wrong?
I did it the equation first, comma X, comma 0, comma 2.
Okay, so let me see. I'm trying to see where I'm making my mistake here. Let me see. So I did my equation, right? Do I have that? Maybe I don't need that. There we go. That might be it. And this is what you came up with?
Yeah.
Okay. There we go. Okay. So, okay. Yeah. So guys, I'm going to show you something real quick like here. And again, and I'm going to show you this because I want y'all to see the simplicity. Let me see if I can turn this guy on. Okay, and I'm going to try one more thing here too. Okay, so let's see. How much I can. This is a stretch, but we try it. Actually, I think it stretched pretty well. See here. Good, good, good. So let me try something here, y'all. Let me stop. You stop sharing that. Let me share the camera. Use your facing right. There we go. Okay. Okay, so you guys can see the screen there, and I'm going to try this. Here we go. Okay, so let me get rid of the microphone. Read it. Okay, so guys, just to give you a heads up, this is me doing this on my calculator app, right? So just like we did before, I went math, right? And I went to number 9, functions integrate. And actually, this is one of the kind of cool things about the app. It tells you exactly how you're going to do it. You're going to go expression, variable, lower, upper. Remember how we were doing it right now? Y'all were telling me, okay, put the expression first, put like the square root of 1 plus 64 squared, comma x, and then the lower and the upper. So when I'm entering in on like the actual calculator, that's the order. That's the order that I would enter those things in, right? So take a look here. Now, so look, I'm going to go from 0 to 2. The square root of 1 plus 64 x squared, dx, and I'm going to hit enter. Kind of neat. You just entered in exactly as you see it, right? So guys, I don't know what kind of phones you guys have. So obviously I'm doing this on my iPad. Guys, I have it on my, I actually have the same thing here on, yeah, I'm still supporting an older version of the phone. But I have this on my iPhone as well. It's called, this app now is called Graphing Calc 83. And when I got it, y'all, they spelled graph Graf, right? Now they spell it like it's called graph. But it's like $6. You know what I mean? It's $6. It does everything that your calculator does. If you have an Android phone, there is one called Calculate 84. This one right here, Calc 84. And now this one here, y'all, I did not pay for it. You can upgrade it. I didn't pay for this one. So if I go to math, look here's function interval. It's actually letting me do this too. I know that for the Android, or for the this is well, I mean, this one works. It also works on the. It also works on the.
Let's shoot those in. I know on your computer there are less than reputable sites where you can get your. You know how you have your program for the 83?
Right.
You can find ones for the Inspire Task 2s that are crazy powerful. They are. I'm not endorsing you to do this, but they're out there.
Yeah. Yeah.
And
So
they're super useful.
yeah. So Jennifer, it's this one here. It's called Graphing Calc 83. It's this one here, the Calc 84. You know, I would say I have this on my iPad as well. It still does the same thing. I know there's upgrades that you can do. I just don't know. So obviously, it let me do this without having to upgrade. I want to say it might come to this part. And there was another app I have on my phone. When it comes to the stats part of it, yeah, that could be. I mean, this one could just be the fact that there's an app. I really don't know. I know that there's another one that I have on my phone. This one here called Calculate 84. And when I try to do some of the stats stuff on it, like I don't have access to it. You know what I mean?
The damage to your phone is the exact thing that
Yeah. So like when I try to do, like I think when I would try to go to the bars, but it was something on here. I don't remember which one it was off the top of my head, but I know when I tried to do some of the stat functions or something, it wasn't allowing me to do it because I guess I hadn't updated. But I don't know. I'm a big fan of that Graphing Calc 83.
All spells you could always do from Wolfram Alpha.
Or you can do it on Wolfram Alpha, stuff like that. And so, guys, when I'm doing these problems here, a lot of times, that's what I end up using. Or like if you've noticed when I've sent you guys videos before, I have, when I send you all the videos, I'm doing those individual videos on my iPad, and I use that calculator app. Right? Like I said, I mean, it works the same way as the regular calculator. It's just, let me stop doing that. Come back this way. Here we go. Okay,
So how do we hand solve this question?
so the way you would hand solve it is you would actually have to go to and use one of these formulas. And I would probably say you would probably have to use something like this formula right here, because look,
We can't do that one.
oh, sorry. Oh, it's still sharing this. Sorry. Thank you, John. There we go. Okay, so if you were gonna hand solve it, my guess is you'd have to use this formula right here, which is like number 68 right here, right?
Kind of looks like,
Yeah, because it kind of looks like when I do this here, right? And I were to come back, say to, let's see if I can paste it here.
you could say one is equal to 1 squared, so therefore. that-
Right. That's right. So if I were to kind of do a little stare and compare, I would say, okay, so in here, I would say, look, my A is 1, so A squared is also 1, right? And then wouldn't my U squared be 64x squared? So then wouldn't my U be an 8x, right? And then what I would do is I would slap that formula on there. But remember, then I'm still going to have to evaluate it, right, from 0 to 2. You know what I mean? And because I'm going to have to plug those numbers in, I'm still going to have to evaluate what is this part, right, when I plug in the 0 and the 2. And what's this part going to be when I plug in the 0 and the 2? And it just gets messy. So my recommendation is use your calculator, because it's going to be much easier. And guys, so if you notice, what am I doing here? I'm doing a definite integral, and I just use my calculator. Doesn't that now mean that when I have to do any definite integral, I can use my calculator? I can do that, right? You know what I'm saying? So any of the definite integrals that we've done before, we can all start using our calculator, right?
Like, the answer is, like, trying to figure out how to do it exactly. If you natural log, the square root of 257 plus 16 divided by 16 plus the square root of 257.
Yeah, it's a whole bunch of mess, right? It's a whole bunch of mess there. Yeah, you definitely don't want to mess with that. So look, y'all, let's do the same thing here. We're going to start with this problem. We're going to integrate from A to B. 1 plus f prime of x all being squared. Okay. That's my formula. Okay. So I still have to know my formula. Okay. There's no doubt about it. I have to know the formula because I have to know what I'm going to plug this into, right? And then we're just going to start off, guys. We're going to say, look, in this case, my f of x is 3x minus 1, right? Okay. Does anybody know what my f prime of x would be? What's the derivative of 3x minus 1? 3, right? Okay, and then one last part, y'all. What is f prime of x when we square it? 3 squared is 9. Okay. So look, now we're going to go ahead and integrate. We're going to integrate. Look at my interval here. I'm still going from 0 to 2. Okay. Of the square root of 1 plus f prime of x squared. We just found that to be the number 9. dx, right? So y'all, everybody agree 1 plus 9 is 10? Okay. Just making sure we still got our skills, right? All right. Anybody know what is the antiderivative of the square root of 10? Because this one, I bet you we can do it by hand. Yeah, it's not that hard. Hold on. It's not that hard. Look, let me ask you a question. Look, before I go on.
So it's going to be 5x squared divided by.
No. Look, let me ask you a question, guys. Oops. What is the antiderivative of 2? Wouldn't it just be 2x, right? So what's the antiderivative of the square root of 10? Isn't it just the square root of 10 with an x? Because it's a constant, right? And if it's a constant, isn't it? So think about it this way, y'all. If I were to ask you, what's the derivative of the square root of 10x, wouldn't it just be the square root of 10? You see what I'm saying? Now look, we're going to evaluate this from 0 to 2, okay? So look, if I evaluate this from 0 to 2, isn't this going to be square root of 10 times 2 minus 0, which is 2 square roots of 10, right? And look, y'all, we can double check this by using my calculator. Let me turn this guy on. Okay, so look, I'm going to do the same thing. I'm going to go math. I'm going to go to my function integral right here. Okay, so we're going to type in the square root of 10, okay, comma x, comma 0, comma 2. And I'm going to hit enter. And I'm coming up with 6.32455. And look, y'all, 2 times the square root of 10. Same exact thing, isn't it? Right? So like, hey, that's kind of neat. This thing actually works, right? And there we go. So y'all, again, I'm not telling you do it by hand. I did this one by hand because I knew we could do it by hand. It was just a constant, right? And when you're integrating a constant, it's just going to be that constant times x, right? But what I'm saying is, for these problems, guys, you're definitely going to want to use your calculator to do these problems. It's going to make it so much easier to do, because otherwise you're having to hunt for one of those formulas. And again, that's the thing, right? When I showed you guys those formulas, y'all, let me come back this way. Look how many formulas there are. There are a ton of formulas, right? And again, like we've talked about, how do you integrate? We've talked about basic integrals, like what's the integral of a sine and a cosine and a secant and stuff like that. But you start looking at some of these trig integrals, look how complicated they can get. So look, if I'm trying to find the antiderivative of secant to the third u, it's 1/2 secant u tangent u plus 1/2 the natural log of secant u plus tangent. I mean, there's a lot of stuff in there, right? And guys, I'll be honest. When I was in graduate school, I remember it was the summer of '97, and I was taking this graduate stats course, and we had to do this some kind of integration, right? And what we ended up having to use was, we had to use one of these formulas. Every now and then you hit a problem, and guys, I don't know what your experience is going to be like in Cal 2 or Cal 3, because I haven't taught those classes, and it's been a really long time since I took them myself. I want to say that at times you end up having to use one of these formulas, but the nice thing is, when you can't figure it out, you can always go to that formula page, right? And you can say, okay, look, is there something here that looks similar to the problem that I have? And can I apply this formula to it? And sometimes you kind of have to do that. Okay, there's going to be times where you're going to have to do that. It doesn't happen all that often. I mean, I can't remember. I remember that one time in that graduate stats course. Did it happen other times? I'm sure it probably did, but it's not like I was having to use this, list of integrals like really, really often. I wasn't having to deal with that, too often. Okay, but it's something that does show up every now and then. Okay. So let's take a look. We got one more problem to do here. Like I said, this is a pretty short section. And it says, find the arc length of y equals 3x to the power 3 halves on the interval from 2 to 3. Okay, so again, first thing I'm going to do here, y'all, I'm going to write down my formula. I'm integrating from a to b, the square root of 1 plus f prime of x squared dx, right? Okay, so let's go slowly here. Everybody agree that my f of x is a 3x to the power 3 halves? Okay, so guys, what would my derivative look like? What is the derivative of 3x to the 3 halves? So remember, we're going to leave the 3 of that. What do we do with this number? Bring it to the front. 3 halves, x. How much are we supposed to subtract from that exponent? We're supposed to subtract 1. Can we think of that 1 as 2 over 2? So 1/2. Good. Okay, so I'm still going to keep my f prime here, y'all. I'm just going to simplify this. 3 times 3 halves is 9 halves, x to the power 1/2. Okay. All right, now what we need to do, y'all, we need to square this guy. Okay. So we're going to square it. So let's do this in pieces. What is 9 over 2 when you square it? Just do it in parts. What's the square root of 9? But remember, you're squaring it, not taking the square root, but you're squaring it. 81 over 4. Okay. Guys, what happens when you square the square root function? Because remember, it's just going to give me an x, right? It's just going to give me an x. Think about it this way, y'all. We have x to the power of 1/2, and we're squaring it. Remember, that 2 gets multiplied right here. So this is x to the power 2 over 2, which is the same thing as x to the power 1. Okay. All right, let's go ahead and integrate here. So we're going to integrate. Look at my limits, y'all. We're going from 2 to 3. Okay. 1 plus 81 over 4 with an x, okay, dx. This is what we're trying to integrate. Again, y'all, at this step, I'm not going to worry about trying to figure out what the integral is. I'm going to revert back to my calculator so I can find that arc length, right? So again, I'll turn this guy on and clear this out. I'm going to go to my math. I'm going to scroll down to the function integral. Okay, so we're going to type in our function, which is 1 plus 81x over 4. Okay. Close that off. We're integrating this with respect to x from the interval of 2 to 3. And I'm going to hit enter, and I'm coming up with 7.1735. Uh-huh. It's pretty messy.
A lot of the same numbers.
Uh-huh.
And negative times 166 times the square root of 166 times 247 times the square root of 247. What about 243?
Yeah, got a lot of mess in there, doesn't it? So, y'all, arc length is super simple to do because we can use the calculator, right? Because we can do it that way, okay? So again, y'all, when I practiced these problems before, I was actually doing it on my app on my iPad, and I did it on my phone. I hadn't even tried the calculator, so when I pulled up the calculator, I was like, "Whoa, this looks much different the way my app looked." Right? My app gives it to you. You know what I mean? Like you can just put the numbers, the interval from 0 to 2. But now we know how to do it, right? Put your function in, comma x, comma your lower limit, comma your upper limit, right? And then you're done. But you can see how easy it is to do, right? These are straight calculator problems, y'all. There's not a lot to it. Your homework, you have 3 questions on here, and I would do every single one of them the same way. Even though that second one here, I could do it by hand. Okay, I did it by hand, but remember, I did it on the calculator too, and I got the same exact answer, right? So, I'm not going to throw myself a party because I could integrate this, right? It was simple to do, but this is really simple to do, right? And I think at this stage, you guys, we have done so many antiderivatives, we've integrated so many times that I think we should feel like we're comfortable that we know how to integrate. You know what I mean? Like if I ask you what's the integral of a cosine function, you would say, oh, it's going to be the sine. Why? Because the derivative of sine is cosine. Stuff like that. You know what I'm saying? Like we should have enough confidence in our abilities to say, I know how to do this by hand, but I'm going to save time by doing this on my calculator. And it's not that I don't know how to do it by hand. Some of them obviously are more complex, and I would have to go back and use that table, and that table of integrals. And why do I want to mess with that? Especially if it's a definite integral, right? If it was something like an indefinite integral, then yeah, I have to resort to the table. But when it's a definite interval and you're plugging the numbers in, it's simple to do, right? It's kind of like if
That's the integral is one with the actual difference.
with the limits, right? The limits are actually given to you. They give you a low limit and upper limit. And when you're doing a definite integral, John, you're finding a numerical value, right? When you're doing an indefinite integral, you're basically finding the antiderivative of the general function, right? So guys, I think about it like something simple. Do you know how to wash dishes? Yes. Do you have a dishwasher? Yeah, I'm going to use a dishwasher, And it's not that I don't know how to wash this up then,
Actually,
right?
in my house, it's not that well.
Why, do you have a dishwasher?
We had a dishwasher since we moved in, like, in 2005. We just never used it because, like, I had a bad experience with dishwasher. It didn't clean it good. My mom got angry with me, and so I never used the dishwasher. And you boy will also wash everything like that. And so
Yeah.
when I watch the
I can see
I'm
this.
like, Mom, but think of the water savings. I'm using like 10 gallons of water every time I wash the dish. That's like two, like max.
Yeah, yeah, guys, I use my dishwasher like all the time. You know what I mean? I mean,
She wants spotless lasagna. Like,
yeah, I understand. Look, hey, it's just, you know, but what I'm trying to convey to you guys is that uh, it like I don't want you to feel like you're somehow cheating yourself by using this, right? Like again, look, this is basically the last day of me teaching you something new, and that today is the day that I showed you how to do this. Well, no, I'm going to be perfectly honest with you. When I was going through this problem myself, the very first question, I was like, this one here, I was like, how do I integrate that, right? And so I was watching the video that comes with My Open Math, and this is how they did it. They used their calculator, right? And I was like, okay. And then the guy says, or you could use these tables. And I was like, I remember the tables. I was like, really? This is one of those problems where you have to use like one of these, you know what I mean? And it's just like I said, guys, the tables. I don't want you to think about. I don't want you to really worry about the tables. And the experience that I had when I was a calculus student was anytime I had to use one of these tables, my professor said, hey guys, look, this is one of these problems where we're going to open up our book and we're not going to look at that section, but we're going to look at the ends of the book where we have these tables. And you're going to have one or two problems, something similar to this. And my guess is whenever you take calculus 2 or calculus 3, I'm hoping that you have an experience like that where you're not like trying to crack your head open doing some kind of integration. And you're like, I never saw this before. And your professor says, did you ever look at the table? Like, did you ever tell me to look at the table? You know what I mean? I hope that you have an experience where the professor says, hey guys, for some of these problems, we're going to use some of these kind of really obscure intervals, and we're going to have to use tables, and we're going to try to see if we can do a little comparison. And okay, can we figure this out? Oh yeah, look, okay, so that's what it is we're doing. And is it a kind of a pain? It is, but it's kind of neat also that with some of these problems, which was the one that we did, I think it was like 68 was our formula, was that 68, that we could look at this formula here and we could say, hey, you know what? That looks very much like what I have here. And when you're able to kind of see like, hey, this right here looks very much like this, and then I can apply my formula and I can actually do it. Yeah, it's kind of a neat thing that when you can do it, but it's not something that you're going to end up doing like, 10 times in the semester. You're going to do this, guys, 10 times in your whole life, maybe. You know what I mean?
Well, there were people before these days that did this with those that tables.
They did it with the
Like,
tables, right?
Like a thing like they're a graduate student, like you gotta memorize at least like 50 of them. Like,
Yeah, and I have a feeling, John, that when you had to do, like these tables have been going on for a long time. You know what I'm saying? So before we had something like this, my guess is if you had a problem like that, your professor said, hey, use your book, right? Use that table, or they gave you a printed copy of the table, and you're able to do that kind of thing. Okay.
You know that when you from math, I think that you loading it up right now. But one of the people who calculated, I think.
Oh, you're talking about Hidden Figures?
Yeah.
The Hidden Figures movie? Yeah.
Like that lady who calculated like by hand. I don't know if it was the trajectory or like, but she had to calculate. I mean, it would be telling you the physics. I don't think they did it calculate, but like.
Yeah, they did though. Yeah, they did.
And just like I'm just thinking of the gargantuan task of trying to calculate all that.
Yeah.
Obviously, it takes weeks, right? Because like that's like some math that.
Yeah, it's a lot of stuff. So guys, anywho, let me see if I thought I still had it here. This should have been there. That's not the book. Where's the book? Access is right there. It tells me, right? So anyway, yeah, you can definitely get the textbook right here, if you need to. But okay, that link obviously doesn't work. But this one I believe does. There you go. Okay, and then if you want to download it, you can download it or whatever. But this is basically the book that I was using when we were, going over this stuff. These were pulled a lot of the problems but we are done, guys. 6.4 was the last section we're doing. Just to give you a heads up, when you guys take Calculus 2, I want to say that you probably do some review of integration, but you definitely go over like area and volume and arc length again. You go over some of those topics again. So there's a little bit of overlap, okay? So whenever you do take Calculus 2, guys, whether you take it this summer or whether you wait till the fall, I'm hoping that the first couple of weeks for you guys is somewhat of a refresher because there is some of that overlap, okay? And again, when I was a calculus student, that's how I did it too. I think that's just something that's pretty standard, you know, because we don't want to necessarily pick up like right where you left off because if it has been some time, a few months, you know, you want to have some of that refresher, right? So again, you guys, just to give you a heads up, on Wednesday, what we will do, y'all, is we will start working on the review. Again, the review is here, you guys. So if I click on it, should be open already. There we go. 30 questions, right? We can go over, say, the first 15 on Wednesday. We'll do the next 15 on Monday. That's pretty much it, you guys. I'm trying to think if there's anything that's due today. 6.2 or 6.3 maybe? 6.3 is not due till Wednesday, right? So 6.2, guys, 6.2 is, where is it? Right here. So 6.2 is due by, yeah, 6.2, guys, is due by tonight. So again, make sure you get that stuff done. Let's see, there was something in the chat here. Okay, so Matthias, you got yours done too? Okay, good. So again, were you able to figure it out on your account on the Casio? Were you able to figure out how to do it on the Casio? I'm sorry? It's the same way? Okay. So guys, that's